Hello friends, in this video we'll study how to measure the higher voltages with DMM having low voltage measuring capability. So for an example, let us consider how to measure the 10 kilovolt, 10,000 volt with a DMM that is having the voltage range, voltage measuring capacity of maximum 1000 volt. So for this, what we can do? The simple solution is we can design a voltage divider. In that there are different resistors in series. Across this total series combination we can connect the total 10 kilovolt and we'll measure the voltage across some part of this total resistance, and that some part will be given as an input to the multimeter. So the multimeter will show the voltage which is the step down version, and it is having some ratio with the actual voltage. So that is why it will be step down version of the actual voltage to be measured. That is, here it is 10 kilovolt, 10,000 volt. So for an example, if you consider how to find this ratio. So here we are having two voltages. First is nothing but the voltage actual which we have to measure, it is 10 kilovolt, and voltage measuring capacity of DMM is 1000 volt, that is equal to 1 kilovolt. So if I take the ratio of this, that is actual voltage divided by DMM voltage, this ratio is 10 kilovolt divided by 1 kilovolt, so this ratio is 10. So what I can do, I can select a series combination of resistors in which the total resistor is 10 times of the resistor across we are connecting the multimeter. Here the two resistors are in series, and say this is R1 is 100 kilo ohm, R2 is 900 kilo ohm. So the voltage which will be appearing across 900 kilo ohm, it will be 9 kilovolt, and the voltage which will be appearing across R1, it will be the 1 kilovolt as per voltage division rule. So you can get the solution, but the problem is this solution will not work because we have just selected the resistance value as per voltage division rule, but we haven't considered here the wattage of resistor, right? So we have to consider the wattage of resistor. If the actual value of the wattage, the power which is appearing across that resistor, if it is greater than its power handling capacity, that circuit will be damaged. So that is why let us find the wattage of this resistor. In this case here, the power which will appear across the 100 kilo ohm resistor, it will be given by V1 square divided by R1. So it is equal to power 1 is equal to V1 is 1 kilovolt, so 1k minus 1k, that is 1 kilovolt square, divided by 100k divided by 100k, so it will be equal to 10 raised to 6 divided by 10 raised to 5. Hence this power across this 100 kilo ohm resistor is 10 watt. Similarly, if you find the power which is appearing across this 900 kilo ohm resistor, in this case it will be equal to V2 square by R2. Hence it will be equal to P2 will be equal to, it is 9k multiplied by 9k divided by 900 kilo ohm. So if you solve this, you'll get this P2 is equal to 90 watt. Friends, we know that with increase in the wattage of resistor, its size increases. So if you consider the 10 watt resistor, it is very big. 90 watt will be very big. In our lab or in our day-to-day life, we are having the resistors which are of quarter watt, the half watt, 1 watt, 2 watt. So these are the resistors which are easily available. But we cannot have these resistors of 10 watt, 90 watt easily available, right? And there one more thing, their size will be very large. Nowadays in the market we are having the resistors with higher power handling capacity, right, with small size, but they are very expensive. If you Google or if you search on net, you'll get the costing of these resistors, right? Their cost is greater than 10,000 rupees also. So that is why this solution is not affordable. So what we can do, I can here I can use the another solution. In that solution, what I can do, I use the resistors such that instead of using two simple resistors, I'll use the higher value resistors, and then I'll check the power dissipation across each resistor. So in case 2, what I'll do, I'll use say 9 mega ohm and 1 mega ohm resistor, right? And across this I'm having the voltage 10 kilovolt. So here again R1 is 1 mega ohm, R2 is 9 mega ohm, right? So the voltage which is appearing across R1 is now again 1 kilovolt, and here across 9 mega ohm it is 9 kilovolt. So in this case, if I find the power which is appearing across each of these resistors, say P1, so it will be equal to voltage square divided by resistance value, that is 1k multiplied by 1k divided by 1 mega. So it is power is equal to 1 watt, right? Then if I find the power which is appearing across this 9 mega ohm resistor, it will be 9k multiplied by 9k divided by 9 mega. So if you solve this, you'll get 9 watt. Again friends, here I can have the 1 watt resistor which is easily available, but this 9 watt resistor, it is not easily available. And one more thing, its size, though it is available, its size is very large. So that is why what I can do, the simple solution is that instead of using the series combination of 1 mega ohm and 9 mega ohm resistor, I will make a series combination of multiple resistors of 1 mega ohm. Let us consider I'm making the series combinations of 10 resistors, each of having the value 1 mega ohm. So what will be the case here? Here I will have the 10 resistors in series. Each of them is having the value 1 mega ohm, 1 mega ohm, 1 mega ohm, 1 mega ohm. So these are the 10 resistors. These are the 10 resistors in series. Each of them is having the value 1 mega ohm. So across this series combination, what I am doing now, I am applying the total voltage of 10 kilovolt. 10 kilovolt. So across each resistor, the voltage available, it will be now 1 kilovolt. And if I find out the power which is appearing, power which is dissipating across each of this resistor, I'll get that power will be equal to voltage across one resistor divided by its resistance value. So it will be equal to 1k multiplied by 1k divided by 1 mega. So you'll get it is 1 watt. So here in this series combination, each resistor which I'll require, it will be of 1 mega ohm, and its wattage is 1 watt. Now this resistor is small as compared to 10 watt resistor. It is easily available. So that is why I can design a circuit of series combination. It is actually voltage divider which consists of multiple resistors of small wattage, small power handling capacity, and across total series combination I'll apply 10 kilovolt, and across some part of that series combination or across one resistor I'll measure the voltage which will be applied to actually DMM. So DMM voltage will be the step down version of the applied voltage. Here let us consider this is A point and this is B point. These are the two end points of the series combination. So and there is third point, that is say C point, right? So what I can do, across A and B point I'll apply the actual voltage to be measured, which is very high voltage, and in between C point and B point I'll connect the DMM. So here I'm having three terminals, terminal A, terminal B and terminal C. So this device is already there in market, or you can design it. So if you consider this device, it is actually called high voltage probe. It is called high voltage probe. So in this high voltage probe, there are number of resistors of small wattage which are connected in series, so that is why they can handle the more voltage, right? And here in between B and C point, you can connect the DMM, and here at A and B point you will connect the actual voltage. So this is all about the measuring the higher values of voltages with the help of DMM, which is having low voltage measuring capability. Thank you.